Hey everyone, welcome back to my channel. Let's start our journey to secure industrial network using Cisco CyberVision. Today we will be starting with third part, that is introducing Cisco CyberVision and design options. Also will request to subscribe to my channel for updates and next more videos. Your subscription and your views help me keep motivated for more videos. Thank you. Today these are the course outlines. So today we'll be starting with Cisco. What are IT concerns with OT security? Increasing attack on OT industries. These OT assets are extremely critical and may also be easily exploitable. Digitization is a driving IT and OT team to be more interdependent, with securing industrial control network from cyber threats as the driver for IT and OT collaboration. It's clear that both IT and OT bring their respective domain expertise for combined impactful solution to mitigate challenges of securing industrial environment. As IT operation take on responsibility for securing industrial network, contexts become more important for creating and implementing security policies. Take for instance an assembly line devices connected in an interdependent system to execute their task. Let's assume one of the devices exhibits symptom of malware infection. In most IT settings, the standard response would be quarantine the device and prevent further spread of malware. On assembly line, quarantine any single device may initiate a cascading failure leading to shutdown of complete production. The cost of such outage may be much greater than the cost of the damage that malware may have caused it. Earlier days, OT network used to be air gap network. This is no more the case. ICS network are most outdated device and do not meet today's. With convergence of IT and OT barrier between both sides has been decreased, and so the attack surface has also increased accordingly. Many ICS network owner today avoid adopting newer technologies like zero trust network just to avoid any kind of downtime. Both IT and OT have different viewpoint about the safety and security of their assets. While OT professional may feel everything is secure and meeting the safety requirement, while IT team while IT team conducts the assessment, they find OT setups when they do the assessment of OT setup, the box gets opened up. They might find a lot of issues which requires to be fixed up. Each team, that is IT and OT, have different need and different set of priorities and ways of working. OT team are concerned about physical safety, security, uptime, etc. While IT team looks from cyber security perspective, considering CI drag. Cisco CyberVision builds the bridge between IT and OT teams so they can work together on securing industrial network and processes. For OT security project to be successful, it is key that OT and IT team brings security expertise. They know what are the best practices that should be implemented and how to fight against cyber attacks. OT team, on the other hand, brings the knowledge of industrial processes. They know which assets are most critical and which event downtime can be threat to the production. Together, they can help build IT security policies that will not disturb the production as well as taking care of the security concerns. Normally, IT and OT network are just segregated by firewall in industrial DMZ zone. This is as per ISA 95 standard or Purdue model. Question to be asked here is only a firewall OT network. So probably answer will be no, it is not sufficient. Securing industrial network requires key capabilities that are very much dependent upon each other. First thing we need is the visibility to our industrial assets. We need to know what out there requires to be patched or fixed, what can be patched, or how to fix a configuration issues to detect any unwanted communication or unknown remote access that might be attempted. While this information, we can segment our network to isolate assets and control communication zones. This will also greatly reduce the risk of attacks spreading to the entire network. Protects a critical asset that cannot be patched. Segmentation makes it much easier to detect any kind of malware or malicious traffic, but also helps to focus on detection strategy. So that can be detected any abnormal behavior, processes, or anomalies. Once we have the precise and accurate visibility into industrial assets and security events with limited false positive, we can feed this information to Security Operations Center for further investigation and to response. Detection of newly connected assets are one of or any recent activities in the ICS network is mandatory. So this we require to monitor properties of asset within the network, and accordingly build up the control on how to remote access or both for management or engineering stations. Also identify and promptly respond to change that may have impact the process availability or integrity. Let's say for Stucknex, that was attack which used to send a stop CPU order or any new controller program into any new program is loaded into controller memory. So such can of any change can be catastrophic to the OT network. So detection of any critical variable change requires a proactive action. So along with this, we require to track any threat to the OT network. So what kind of network is underlying? What vulnerabilities are with that network? Authentication protocol, authentication flows, protocol flows, any port scan that has been detecting a signature. Along with this, if we have IDS or anomaly based signature based detection, this also helps to detect the attack faster. OT control are completely different than regular IT traffic. It could have like variable changes, uploading of the program file or firmware updates, assets, inventory change. We also require to monitor any kind of asset change or removal. So these are most of the time inbuilt into our Cisco CyberVision, and its administration also requires to be accordingly. Next is to track any kind of security events using presets. So tracking a security incident is an ongoing process. So it's required to be fine-tuned and optimized. So there could be a port scan or remote access. There is a remote access. First time it may give alert, but it could be a genuine remote access. Accordingly, the processes and presets has to be optimized. So the remote access, the authorized remote access are not a part of the any triggerer. So it could be like incomplete traffic flow, a change in flow volume. So this we can create a presets and accordingly, like this presets can be based on sites or production lines, or based on the asset type or vendor type. So multiple types of presets created in the Cisco CyberVision. Next is to create a customized detection plan. So once the baseline has been created as per the behavior, then any anomaly or any change in the baseline has to be detected and alerted. So this is just a snapshot view of how abnormal behaviors are being tracked and displayed in Cisco CyberVision. Also, we require to identify the important security information, like which are the top DNS requesting machines, or where the HTTP requests are been originating, which are the SMB trees requests that are been taking place, or any kind of fresh flow which doesn't have a tag information to it. So we require to have those kind of insights. Having IDS not engine running on the sensors to detect any instruction or malicious traffic. This IDS engine can detect various type of attack, exploits, and vulnerabilities. Additionally, with help of Talos signature update, latest threats can also be detected at much faster pace. So this is we can have like signature based filters, which can we can filter out our events based on signature based detections. The signatures normally are downloaded from Cisco Talos. There are a long list of or long set of protocol for communication which are inbuilt into Cisco CyberVision. This list keeps on increasing. So this is the typical field communication protocol normally used in OT network. So if it is a DCS or distributed control system, so these are normally the vendors or protocols which are being utilized. So we can get the updated list of what is the protocol supported. The source is we can go to Cisco CyberVision 4.1 protocol support. This list will keep on updating, and as per the version those are been released. So this is the list of automation and SCADA vendors which are already incorporated, and this is the list of IT protocols like or BGP or any authentication or SMB which have which can impact our production network. Almost all the OT network does not have exact hardware inventory. This is the major problem. Because this have been these devices or OT devices are deployed a couple of years back, and nobody has those in a detailed inventory and what version of software that is running on this devices. A lot of time OT devices are installed at remote location or difficult to reach location. As a result, keeping track of hardware component and software version is a daunting task. Next challenge is we can say is a lack of awareness of exact traffic to whom. So it is like predominantly east-west traffic flow is not normally captured, and customer might find it really challenging to understand the intricacies and nuances of the network traffic overall. This can lead to difficulty in optimizing network performance. So basically we don't have the exact detail of network traffic. Next is the prevalence of large L2 domain. Because of older devices may have restrictions of IP addresses that have been used, or it has already be, or it has to be on the same L2 domain. Occasionally ring topologies. So these are kind of challenges become more and more complex because it is a large L2 subnet domain. In a lot of cases, static are been assigned, and which makes a very limited flexibility to the overall infrastructure. Uh, a lot of time OT devices even don't support authorization or authentication mechanism. So it like 802.1x or something like that, it's not supported. So minimum interaction once they are installed, it is like plug once and forget it. But the scenarios are changing, and that's the reason they are also been exploited more and more. Security solution designed for industrial network typically monitors the network traffic to gain visibility on assets, behavior, malicious traffic, and threats. So based on the solution, how we are looking to secure the network, one product or multiple combination of product just to achieve that how we can secure our OT network. Cisco CyberVision can be key to securing OT network by detecting security events. Based on those events, create a actionable fine-tuned process or to reduce false positive. This solution can easily scale to support large OT network and effectively support the OT collaboration. Cisco CyberVision is a purpose-built. Let's switch down to Cisco CyberVision. Cisco CyberVision is a purpose-built security solution tailored explicitly for industrial network. This architecture provides holistic approach to the protect our OT network. This offers a range of abilities to mitigate cyber risk. This has basically two major components. So first will be Cisco CyberVision sensors. Those CyberVision sensors are the designed to capture the network traffic and run DPI or deep packet inspection for and send the metadata to the Cisco CyberVision Center. Cisco CyberVision Center, which does all the analytics, integrate with third-party solutions. So all the integration with the third-party solutions, and integration with sharing the OT context with the rest of the Cisco's other solution can be taken care. This is Cisco CyberVision is normally accessed using GUI or API base. CyberVision architecture is basically a game changer for industrial security, supporting the various features like deep packet inspection, asset discovery and inventory, anomaly detection, threat intelligence, real-time visibility on control, enhanced posture. It also helps to make the or maintain the regulatory compliances. So seamless integration with Cisco's ecosystem. As a part of ecosystem, Cisco CyberVision seamlessly integrate with other Cisco solution as well. Like it could be Cisco DNAC or Cisco's firewall or Cisco's identity service engine, analytics, SecureX. So multiple Cisco products are also seamlessly integrated. Cisco CyberVision can set up can be scalable as needed. Deployment can be single CyberVision or multiple CyberVision, multiple separate CyberVision. So we can have like only just one single CyberVision that is running, or multiple separate CyberVisions that are been running, maybe due to different location connectivity or administrative requirement. And last, it could be single CyberVision supporting multiple areas. So single CyberVision supporting multi areas. For customer with multiple factories or extremely large spread out, can have multiple CyberVision, say one CyberVision in London, one CyberVision somewhere else, and those are being and the feed to global center centrally. This is a global center monitors. It's a monitors all the feed from coming to each of the CyberVision instances. Okay, let's come down to Cisco's CyberVision hardware. So Cisco's CyberVision hardware can be can run as a hardware, dedicated hardware. We have two options of dedicated hardware. Both are M5 machine as of now, M5 S5 and N5 S3. It could also be running as a virtual instances. This could be running on VMware EXI or Microsoft Hyper-V, or even on the cloud like AWS and Azure. Scalability perspective on dedicated on-prem hardware. So these are number of components that could be devices. So S3 is bit on the smaller scale, and S5 is on the larger scale. So based on the design or scale that you're looking at, we can design. So these are basically M5 servers which are been customized to run Cisco CyberVision. Let's look how CyberVision is normally placed. So when center is located in IDMZ zone or OT domain, dual cyber interfaces are preferred. So in this we can have like two Ethernet interfaces. This is Ethernet interface one. It's purely going to your OT network, that is your collector information, and other interfaces are going to your administration or outside zone where using GUI we can connect. So basically it also helps to maintain the security, as both the zones are not physically merged. So both are having restricted access. Like this, one interface will only have admin interface, and other will use purely for the collection purpose from the sensors. If it is a small network with single interface deployment, both function will be combined onto that single interface. CyberVision Global Center provides a global perspective of the entire organization. Each or plant is monitored at central location, which global center collecting all the information from each of the Cisco CyberVision center to allow the entire environment to be monitored from single SOC. Global center provides additionally features like asset inventory, vulnerabilities, summary of activities, information of the preset, central knowledge. So a lot more features are being supported. Typical OT detection solution normally works like it spans the traffic. So all the traffic from your OT network, all the ports are basically spanned across to a parallel network of switches, and those span traffic is then sent to your the respective server appliance of that particular OEM. So this normally requires a parallel setup to be set up. So if we have, let's say, a couple of switches, then here also, because all the traffic has to be collected and spanned across, so accordingly parallel network has to be set up. So normally such kind of solutions are not scalable. It also with remote span kind of scenario, it can create a lot of overhead if it is using the same infrastructure, just both for OT traffic as well as for the span traffic. Also, creating a parallel network can be challenging. Like this is a typical office floor, it could have a long. So creating a parallel network or having a tap point can also be really challenging in such kind of scenarios. Cisco has completely different or approach to mitigate this issue of spanning. So what Cisco does is have a sensors running on the data side or OT network side, which do a deep packet inspection. This is built into the network. This deep packet inspection creates a metadata via firewall. It's not mandatory, but metadata is basically shared across to Cisco CyberVision. Here the central analytics is been done, so there is no more need of setup because metadata consumes extremely low bandwidth of few kbps. So it may, in this scenario, it may require changing a couple of equipment in a brownfield setup, but if it is a greenfield setup, it becomes really easy to deploy and scale up. Let's unveil the magic behind the Cisco CyberVision sensors. So before we deep dive into nitty-gritty detail, let's get the clear understanding what Cisco CyberVision is all about. Cisco CyberVision is a specialized device designed to monitor, analyze, and network traffic with industrial environment. It acts as a eye and ear, ensuring that industrial network remains secure and free from the cyber attacks. So this features of the industrial network can be like passive or flow, or it could also generate active or queries to the devices. This sensor devices run deep packet inspection. So deep packet inspection at a heart, sensors like concept of deep packet inspection. But what exactly deep packet inspection? Think it as if of X-ray vision of a network traffic. The sensors capture and analyze each and every traffic that data is traversing the network and driving into the context and scrutinizing if there is any signs of malicious activities. It can also helps to get a real-time anomaly detection. So sensors goes beyond merely just inspecting packets. It employs advanced machine learning to detect anomalies in real time. By continuous this it is continuous process. By continuously learning the normal behavior of OT network, and sensors can swiftly identify any deviation from that might be potential threat to the network. Other could be used as for asset discovery and inventory. So this helps to keep track of all the connected devices, so which is a big achievement because the way how OT networks are or factory floors are been designed. So CyberVision is excels in this task. It diligently create and maintains a comprehensive inventory of all the devices within the network. This asset discovery process ensures that network administrators have a complete visibility industrial infrastructure. This also seamlessly integrates with Cisco CyberVision to enhance the overall security of ecosystem. The Cisco CyberVision sensors integrate with Cisco CyberVision architecture. This integration allows for centralized management approach, uh, and where all the sensors collects the data, analyze, and provides a holistic view of the network. This doesn't have, normally you can say that this has zero impact on the network performance because it the overall impact, if it is a sensor running, its separate core has been defined, or the way the things are been designed, so it is almost zero impact on the network performance. Help for proactive incident response. So this is, we can say that this is the guardian of industrial network. So Cisco CyberVision, this is as per data sheet of July 2023. So we have three options. First options we can say as a hardware appliance. So this is a dedicated IC3000 appliance, and it can capture all the traffic normally with the single hop of the infrastructure. So this is option number one. Option number two are basically network sensors. So this is a list of the network sensors that will be supported. So it could be your range from rugged switches to 9300, 9400 switches, or even Rockwell Stats or Stat 6 80. And the third is the Cisco also has a inbuilt sensors into Cisco CyberVision software. So even if we can span and collect the data, normally for the data center, we can use simply the span infrastructure just to use inbuilt Cisco CyberVision software also. So how do we decide where to place these sensors? If monitoring all the traffic at Purdue level 1, 0 and 1 requires an expensive out of span network. Monitoring all the traffic, so if it is, we want to capture all the traffic from the sensors, so it could be a challenging. if we collect from Purdue level or aggregation layer, then it will only give the result of north-south traffic, that is traffic that is going out of the network. It won't capture the traffic which is between the PLCs and various devices. It won't be capturing. So instead of creating OOB network, we can also try to use RSPAN to in the network, but normally RSPAN is to be avoided, which as it creates a jitter. So we can have capturing the traffic from each of the zone, and using various sensors. It could be from your Purdue level or aggregation Purdue level 2 and Purdue level 3. So as we have already learned about three types of sensors that is supported by Cisco CyberVision. So IC option number one is IC 3000. This is a hardware sensors. Sensors are typically designed to typically capture the traffic from designated network and send a meaningful data to the Cisco CyberVision. Sensors are enrolled into the Cisco CyberVision, and both the components are in continuous communication. So both sensors and Cisco CyberVision are continuously interacting with each other. Normally in IC3000, it has we can capture from 4 different interfaces or 4 different networks. So it has 2 copper and 2 fiber. It could be populated with copper also. So it has option to capture from 4 different networks. For initial communication during installation, sensors should be reachable to the sensors collector interface, and requires a couple of port that has to be communicated. Most important port is 5671. This is normally used by AQ, AM, PQ or TLS. There are a couple of additional port requirement like NTP, that is UDP port 123, syslog like 105, 514 or SSH. So these are sort of optional ports. IC 3000 industrial gateway is a edge computing. So we can host. Normally, what we are doing is we are hosting an application onto this edge computing. It could be close to the field in the actual OT sensors like meters or etc. Whichever the OT use case might be. IC 3000 can serve the purpose of any kind of legacy setup. So we don't require to change any switch or any kind of sensors or anything has to be changed. It is just we place an additional IC 3000 and span the traffic to this IC 3000. So this app allows the traffic in both offline mode or online mode. And once the analytics has been done, it sends the traffic to Cisco CyberVision. Normally this is metadata is very low in bandwidth. It consumes around hardly 10 to 15 kbps of the bandwidth. If we have multiple zones, then we can have multiple IC 3000 placed in each of the zones, capturing the traffic. So as a best practice, we can have say that we will require one IC 3000 per cabinet. This is normally for the brownfield. This is the easiest way to deploy in any kind of brownfield without replacing any single device. Traffic is collected via span, and it can capture up to 4 interfaces. This is an application that is running in IOX. After analytics, the lightweight metadata from the sensor is sent across to the center without need of any dedicated sensors or span network. So it also has, this computer is edge computing, so it has a few limitations also, like it can have a maximum scalability of 12,000 packets per second or 15K flow that it can be managed. Option number 2, inbuilt sensors. So all the information, like if it is a data center on Purdue level 3, the data is sent directly to the to the Cisco CyberVision for deep packet inspection. So it could use existing leverage network also. The third option is inbuilt sensors into the switches. So it is like 2-in-1 devices. It is a switch cum sensors. So we can use IC 3400 or probably I 3300 with 10G interfaces, or Catalyst 9300. So list is already shared in earlier slides. And in case this link between the Catalyst or switches sensors goes down, then still that data or deep packets are locally stored and uploaded once the connection has been resumed. So it eliminates any loss of any monitoring data. Cisco's iOS XE it runs on the switches like 94 and it reserves a dedicated memory and CPU. So it doesn't impact, because of the reservation, it doesn't impact the existing switch device performances. And this dedicated is purely used for application hosting. So this provides a separate execution space for user application without compromising the integrity or performance of the switch. Application has to reside on external storage like SD card or SSD based on the switch type that we are proposing. So this is like internal architectural layout on how the exact traffic flow happens inside the switch. So this is the switch ASIC or layer 2 architecture. It trunks to iOS XE, which has a dedicated CPU trunks, and like interface Ethernet 0 is basically used for administration. Ethernet 1 is typically used for spanning or receiving the span traffic. So okay, let's see Cisco CyberVision capture modes and placements. So your design can be any one or any combination based on the current setup or how we are designing for the customer. So basically for capturing, we can use port mirroring technologies like span, rspan, espan, or we can also use tap or like active or passive span. So selecting an optimal capture mode is based on the how customer's network is or planning to deploy. So prefer to have a capture sensors in each of the layer 2 segment or each L2 subnet. Because if this crossing a layer 3 boundaries like gateway or intervalent route devices come in between, then there will be problem because we will not be able to capture MAC OAU, and all the traffic we will not be able to, based on this OAU, we will not be able to identify the asset correctly, and all the traffic layer 2 traffic will not be visible in this given scenario. If we compare with other OEM sensors, typically other OEM have a limited field sensors capability. So I could say that there are three types of sensors. One is type 1 remote collector sensors that which collects 100% of the traffic for visibility and detection, requires a dedicated span port and avoid. So this is a dedicated span port or separate network has been created just to avoid any bottleneck to the existing setup. Second type 2 is where we try to use the same infrastructure. It works basically by compressing the traffic using software and then sending this traffic to compressed traffic to centralized software for visibility and detection. This compression can help to reduce the traffic overhead by, let's say, 20 to 50%. Sensors is something similar to Cisco. These sensors are with DPI capability and require a dedicated compute on the edge. But normally, unlike like Cisco, like IC3000, it doesn't manufacture edge computing. So customer must also ensure that edge computing devices are rugged enough for field environment. There may be other restrictions, like few OEM will need logging into field sensors to capture more flow detail. So it doesn't send the flow detail directly to the centralized application server. So this is done just to avoid the bandwidth congestion. Also, sensors can be support both active and passive detection, time captures, and capturing even traffic behind net. So that has to be ensured that any other OEM can do all this capability. Also, normally other OEM sensors does not support customized IDS signatures or update from regularly from open source like Snort. There is a dedicated requirement for flow of traffic between the devices. There are basically four set or type of devices, and each will have a different set of requirement of ports that has to be open. So it could be administrator accessing client or Cisco CyberVision or field sensors or global center. So and typically these are the ports or combination of ports which by each of the devices, and the direction of the flow will also depend. So I will request if you can visit Cisco CyberVision architecture guide, and which has exact flow requirements for each of the devices. From the Cisco CyberVision licensing perspective, there are as of now two major licensing, that is essential licensing and Cisco's advantage licensing. And for Cisco's IDS, we require as per sensor IDS or license additionally. Thank you, and will request to subscribe to my channel for more updates and next part. This will keep me motivated. Have a good day.